And we're looking at concentration. And yes, we've already done some questions on concentration on the assignment, but it's revision from Phys Sci. We use C equals N on V. Concentration is in moles per litre. And that's how much stuff we've got, how much stuff we've got in that solution. N is moles, and the volume in litres. Can we not be talking, please? Which makes the units for concentration make sense, surely, in that if we're dividing moles by litres, we would expect the answer to be moles per litre. This is the part that most people forget to do because we're measuring mils, don't we, by and large. And therefore we must convert to litres. Which means dividing by 1,000 to go from mils to litres. We can, so yes, the most common way we express concentration is in moles per litre, but we can also be asked to give a concentration in grams per litre. And even though this is very easy, because we do it infrequently, students can find this harder than this one. We'll have a look at this now with our first example. We've got 15 grams of copper sulfate in 355 mils of water. So what's the concentration? And those of you in my Phys Sci class, I think I asked you this last year, what's the volume going to be after I add 15 grams of copper sulfate to the water? What's that? The same. It's the same. Why is it the same? Surely if we add something... It
dissolves because it goes in like the water molecule or something like that.
It dissolves, yeah. It doesn't go into the water molecule because if it went into the water molecule, that would be a chemical reaction.
It fits in the space.
That's the whole
It fits in the spaces in between, that's right. And so that's why the volume stays the same. We want to find the moles of copper sulfate, and we have been given a mass, so we need to use that relationship there. The sample mass divided by the molar mass of copper sulfate, and I'm just going to use the one that's in the book. So that's how many moles we have. And we're asked to find the concentration, and we're going to use this relationship up here, moles divided by the volume in litres. So the concentration of the copper sulfate is the moles divided by the volume in litres. If we wanted to find the concentration in grams per litre, what would we do?
Divide it by 370. Actually, no.
Multiply by the mole mass.
Sorry about that.
Or can you multiply by the mole mass?
Yeah. You just divide the number of grams you have by the number of litres.
So in this example, we've got 15 grams in that many litres. Tells me the grams per litre.
If you're going from, you can concentration in moles per litre, can you multiply by the molar mass to get it in grams per litre?
Oh, so you're just going to reverse this calculation.
Yep.
So it's easier to just start from,
Yeah, but some people don't have that grams.
right, yeah, so if you know that's how many moles you have, then yes, then you could,
It is by grams.
yeah, you could then multiply, which is just reversing that step there, yeah. So the second example, calculate the mass of sodium hydroxide necessary to produce 100 mils of 0.5 moles per litre solution. And this is very similar to what you've done in the titration prac, only you were measuring out, I believe, 1 gram. So let's look at the second example. We want 100 mils. 4 sig figs. So if I convert this to litres, 0.1000 litres. Yeah, because it's 4 sig figs. And we've got a concentration, or we want a concentration of 0.500 moles per litre. Well, this one's 3 sig figs. So with my final answer, it will be the 3 sig figs, because I have to take the one to the least sig figs. Moles of sodium hydroxide. Well, if this is our concentration, moles equals the concentration by the volume, doesn't it? If I rearrange that formula, N equals CV. 0.500 times 0.100, 0.0500 moles, 3 sig figs. And we were asked to find the mass that we needed. So we know how many moles we need, that's the first part. Now we need to find the mass. So N equals little m or big M. Sample mass is equal to the moles times the molar mass. So the sample mass of sodium hydroxide equal our moles multiplied by 23 plus 16 plus 1.0 plus 2.00 grams. Okay, so 2 steps to get to the mass. First we need to find the moles, and like I said, 95% of questions you'll find the moles first, and then once we know the moles we can then calculate the mass. There's some questions on page 38 for you to do now.